Okay, so what we're going to do today is just practice that skill of finding the rule from a table of values. So key definition is that a rule can be stated, or a straight line can be stated as y equals mx plus c. Now recall that the different parts of this, so that thing there is something very important, and that thing there is something very important. So the gradient is the change in the y values as the x values increase by 1, and that's the value of m. So once I've found that out, I can simply replace m with what I find as the answer to this, the gradient. And then the y-intercept occurs when x is equal to 0. Okay, and this is the value of c. Note that that can go straight into there once I find it. Okay, so let's try that out on a table of values here. So state the equation that matches the table of values below. So here's our table of values. Now, our first job is to find out the gradient. The gradient is the change in y values as the x values increase by 1. So what you can do is look at the table of values and find a spot on the table of values where the x value increases by 1. So I'm going to choose this spot here, and I notice that the x values change by 1. So what I do is I look at the change in y values at that time, and it's plus 2, okay? Or they change by positive 2. So that means my m, my gradient, is going to be 2. Okay, so it's very important to note that now that I've just found out the gradient. Okay, and my y-intercept occurs when x is equal to 0. So what you do is you look across the x values and you try to find out when x is equal to 0 what y is. Okay, so when x is equal to 0, notice that what y is, it's 5. Okay, and that's the value of c. So we're going to say that c is equal to 5, and our equation is going to be y equals 2x plus 5 based on y equals mx plus c. So m is 2, so that goes there, and c is 5. And don't forget, once you have, or think you have, found the equation, all you do is try it out. So try to substitute a number in. When x is equal to 1, you find out what your equation says that y should be equal to. So let's try it. Y equals 2 times x is equal to 1 plus 5. Y is equal to 7. So this equation here seems to be suggesting that when x is equal to 1, the y value is 7. Is that true? Yes, it is. When x is equal to 1, the y value is equal to 7. So you can be pretty confident that you've got the equation correct. All right, let's look at this one. So again, what we want to do is find out our gradient. Now, the gradient is the change in y values as the x values increase by 1. So you look for somewhere in the table of values where the x values increase by 1. So I'm going to go from 1 to 2. Right, so notice the change in x values. So we go plus 1. These values here go down by 3. Okay, so noting that it's negative 3. All right, so that means that our m value in this case is negative 3. All right, what's our c value? Remember, the c value is found by finding when x is equal to 0, you want to find out what the value of y is. And here it is here on the table of values. So c is equal to 6 when x is equal to 0. All right, let's write our equation. I believe it's y equals negative 3x plus 6. Let's try it out on x is equal to 3. So y equals negative 3 times 3 plus 6. Negative 3 times 3 is negative 9 plus 6 is equal to negative 3. This seems to suggest when x is equal to 3, the y value is negative 3, and that matches up perfectly with the table of values. So I'm very confident that that's correct. Okay, part C. All right, so remember what we do is we look for a situation where the x values in the table of values increase by 1. Now notice that that doesn't happen here. Okay, so it goes from 0 to 2 to 4 to 6. Well, what I suggest you do, in fact, is you make it happen by adding some things into the table of values. So we've got 0 to 2. Why not add 1 in between there? And why not add 3? And why not add 5? Right, now what we'll do is we'll try to complete the pattern. So we go from 0 to 1 to 2, it's 5, and then it's 9. So what do you think would happen in between? Well, I think the value would be 7. And between 9 and 13, I feel like the value will be 11. And between 4 and 6, I feel like the value will be 15. Now, does that seem to look like it works? 5, 7, 9, 11, 13, 15, 17. That's correct. All right, now why did we do that? Well, now our table of values, so we can add these kind of into the table of values. We can find a situation where the x values increase by 1. So let's go from 2 to 3. That's plus 1. What do the y values do? They go up by 2. So m value is going to be positive 2. Now, our y-intercept occurs when x is equal to 0. So we find out on the table of values when x is equal to 0, and we note the value of y, which is 5. So that means our c value is equal to 5. Y equals 2x plus 5. And make sure you test it. Let's test it on the very final one here. Y equals 2 times 6 plus 5. The answer should be 17. Let's see what happens. 2 times 6 is 12. 12 plus 5 is 17. It seems to suggest when x is 6, y is 17. And that certainly matches with the table of values. Again, I'm very confident I'm right. Okay, over here, what we're going to do is find a situation where the x values increase by 1. So let's go from 3 to 4. That's plus 1. Let's look at what happens here. It goes down by 2. That means our gradient is negative 2. All right, now our y-intercept, it occurs when x is equal to 0. And the problem is that we don't have an entry for that in the table of values. But hang on a minute, if I write an entry here, I can just complete the pattern. So I'm going to put another cell in here and write down 0. And then I'm going to try and look at the pattern. Right, so I can see it goes 3, 5, 7, 9. This one must be 11. So when x is 0, the y value, I believe, will be 11. That means our c value is 11. Let's write our equation, or what we believe it to be. Y equals negative 2x plus 11. Let's try it out on one of the values. I'm going to try this one here. So y equals negative 2 times 2 plus 7. Y equals negative 4 plus 7. Y equals 11. I wrote that down wrong. So I knew I was about to get that wrong. Negative 4 plus 11 is 7. So this seems to suggest when x is equal to 2, the y value is equal to 7. So my equation, I believe, is correct. All right, let's try this last one here. This is a bit of a tricky one. All right, when x is increasing by 1. So we want to find out a situation where x is increasing by 1 and it doesn't. Let's pop a negative 2, a negative 4, and a negative 6 in there and see if we can complete the pattern. All right, what would happen between 22 and 26? Well, I believe that that number there will be 24. This number here will be 20, and this number here will be 16. Okay, so now we can have a situation where x increases by 1. What's the change in y? It's 2. So m is equal to positive 2. All right, our y-intercept occurs when x is equal to 0. And we don't have that either. But notice that we've got a negative 1 here. So what we can do is add a 0 and note that every time x goes up by 1, the y values are going up by 2. So this one here will be 28, I believe. So a c value is going to be 28. Let's write our equation as y equals 2x plus 28 and see what happens. All right, so let's try out this one here. We'll try out x is equal to 3. Y equals 2 times negative 3 plus 28. Y equals negative 6 plus 28. Negative 6 plus 28 is 22. That seems to suggest that that is absolutely correct. Okay, so there's 5 different variations on the problem. So what I recommend you do is do heaps and heaps of those. Once you actually understand that, there's not a table of values going around that you actually can't do that for.